Okay, now let's talk about wherever we left off yesterday, if I can even find the right thing. I asked you to do number 6 in the notes, right? Given that 3 is a zero of this function, find the other zeros. Some things to notice here, again, just thinking kind of along the lines of, test question that doesn't tell you what to do. How do we decide what we need to do? What we're trying to do is find the zeros of this function, which means solving x cubed plus 2x squared minus 11x minus 12 equal to 0, means solving that equation. Solving this equation, well, it's degree 3, it's cubic, so we don't have any general formula. And the only other thing I might try here is factor by grouping, maybe, because you see 4 terms there, so you can sort of pair them up. But mess around with that a little bit if you want. It doesn't work here. There's no way to group in a way that you're going to be able to take out a common factor. So the thing that the problem statement tells us is that 3 is one of the solutions. So when I work through and solve this, one of the solutions is x equals 3, right? I'm giving you that. I'm asking you to find the other 2. What that means that x equals 3 is a 0 because of the factor theorem, that result we talked about yesterday, that means that x minus 3 is a factor. So by giving you a 0, I'm also giving you a linear factor of the function. What that tells us then is that if I can divide by that factor, divide that factor out, then what's going to be left is going to be lower in degree, lower in complexity, right? Specifically, this thing's degree 3. If I take out a linear factor, what's left behind is quadratic, and then we can solve that. So what we need to do first is divide by x minus 3. Where do I want to do this? Let's just forget about that for a second. So we need to divide x minus 3 into x cubed plus 2x squared minus 11x minus 12. You can do that either by long division or synthetic division. I think we talked about both yesterday, right? Do you guys have a preference? Synthetic. Okay, so we can probably just run through both real quick. The only drawback to synthetic division is that it only works if you're dividing by a linear thing. But at least for this class, we're only ever going to be dividing by a linear thing anyway. So it's fine. If that's what you want to do all the time, that's fine. If you end up going on to Calc 1, you might have to pick up the long division thing again there. But that's somebody else's problem in the future, right? That's a problem for the future version of you if it applies to you. So yeah, synthetic works fine. But like I said, we'll just run both real quick. Okay, so this into that, x cubed divided by x is x squared. And then multiply these, which would be x cubed minus 3x squared, and subtract. 2x squared minus -3, so that's going to be 5. Carry the other stuff down. And then we just start kind of iterating on that. We just do it again, right, with this. So plus 5x multiply would give you something like that. -11 plus 15, so 4x minus 12. X goes into that 4 times. So 4x minus 12 and subtract. And we get a remainder of 0. Which again, like because of the problem, because of the setup, because of the statement of the thing, 3 is a 0. If 3 is a 0, then this must be a factor. If that's a factor, then when you divide by it, the remainder's got to be 0, right? So again, this is kind of your check that things went the way they should. We talked a little bit about this yesterday, but on like homework where you got kind of unlimited time, if you didn't get 0 as the remainder, it means something went wrong somewhere. So I would just toss it and try the division again. On something like a test, you probably don't have time to toss it and start over. So if you got a remainder that's not 0 here, that's where you might, just say like, I know something went wrong. I don't have time to fix it, so I'm going to go on and finish solving. Let's just run through that real quick one more time with synthetic division. So synthetic, again, you just take the coefficients and like list them in order. So 1, 2, -11, and -12. And then the 0 that we were given was 3. So I'm going to put that right there. And the way the synthetic division actually works, you carry this thing down. Then you multiply these. So 3 times 1. And put that right here. And then add down the column. So 2 and 3 is 5. And then we start doing it again, right? So multiply those. 3 and 5 is 15. Add 11, -11 and 15 is 4. Multiply. 12. And add, and that's 0. The last thing there is the remainder. So again, that's good, that's expected, right? That we get a remainder of 0. That's kind of what we need, or it's our check that things went right. And then the quotient, those are the coefficients. So it's x squared plus 5x plus 4. So either way, we get to the same place. Whichever of those you're more comfortable with, like I said, is fine because all we're ever going to be dividing by is linear stuff anyway. So synthetic division is perfectly fine. This is a little bit like cleaner and faster to write down, but the way it works is also kind of like mysterious, I guess. Like these things are hopefully kind of self-apparent, like where things are coming from. This you just sort of do stuff, but once you've done it a bunch and have a feel for it, then probably doesn't matter anyway. Okay, then what? We haven't answered the question yet, right? The question was find the other zeros. So what we've just learned is that this thing factors into x minus 3 and x squared plus 5x plus 4. So zero product property says that x minus 3 is 0 or x squared plus 5x plus 4 is 0. And then we just need to solve from there. It's quadratic. This one factors plus 4 and plus 1. So our zeros are -4 and -1. I mean, technically all of them are 3 and -4 and -1. The question asks for the other zeros. That's not a thing that I'm going to make a big deal about or count off for. Since it says the other zeros, I'm just going to those 2. Okay, so kind of 2 big things. One, we got to do the division, right, which is its own thing. And then 2, we got to use that to sort of finish solving. So does anybody have any questions about that? We okay with how that works? I know the division part of it, you probably are still kind of, getting up to speed on that. That's okay. Just do it a few times until you start to feel comfortable with it. Hopefully the solving part is not a big deal, and usually, on something like a quiz question or a test question or like this, I try to write these so that once you've done the division, the thing that's left to solve should be like pretty straightforward, like a thing that factors kind of nicely, or quadratic formula doesn't look too bad. Because that's not I don't want that to be the hard part of the problem. The division is enough on its own, so the solving part should be not too bad. Okay, everybody good? Okay, so if you don't have any questions or anything, I don't have anything else to like add, really. We just need to spend some time working problems. So there are other practice problems, I assume, that you haven't done yet on the 4.2 stuff. If we just kind of look at those real quick. 3 says use division and the remainder theorem to find f of 2 for this function. Remainder theorem says that f of 2 is the same thing as the remainder after dividing by x minus 2. So what you would do there to answer this question, really what I'm driving at here is that just practicing division stuff again. So divide this by x minus 2, and whatever you get as a remainder, that's the same thing as just plugging 2 into the function. Now again, that's not how you would go about finding f of 2, right? You just plug 2 in, but remainder theorem says that it works, and it's an excuse for us to practice division. 4 and 5, where it says use division to determine if 3 is a 0. What you would want to do is divide by x minus 3, or divide 3 in using synthetic division, right? Here you would want to divide by x plus 1, or again, do -1 in using synthetic. And then the question is, determine if that's a 0. Well, that will come down to whether the remainder is 0 or not. If it's a 0, then it divides in evenly, so it gives remainder 0 when you do the division. If it's not, then there's some other remainder left over when you do the division. So again, really just practicing doing the division part of things. And then 6 we just talked about. 7 is the same kind of thing, just practicing with division. So the rest of our time today, work on that stuff if you want. You want to do a couple of those and like feel like you're pretty comfortable with the idea, then go on. Like it's notes. I'm not going to take anything up or whatever. And then I'm gonna go ahead and hand this out to you. This has six problems on it that just kind of come from all of the stuff that we've talked about. So just some more extra practice stuff for solving complex numbers, completing the square. There's another division problem on here. There's a polynomial graph, and then there's like an application for quadratics on the back. So just some more extra practice stuff. I am probably, I'll send an email out about this too, but I'll probably like Thursday when we get back from break, have you, turn this in, or at least I take a look at it as like a quiz grade. So that's the end of the sentence. So no one else to say, but I'll just bring these around. But y'all work together, ask questions, try to use this time, wisely to do whatever we need to do to get ready for next week. Yeah, so. Yeah. Well, okay. Sorry, just to clarify. A second ago, I said something about like I usually write, problems so that after you do the division, the solving part shouldn't be that bad. I mean, specifically for like a test, a quiz, something like that. In nodes, like what number is that? 7. The quadratic you get at 7, you're probably going to need to use quadratic formula. It's not going to come out like
really pretty, but that's okay, right? Yeah.
I don't mind a thing that takes a little bit more work on something like notes, but. That should be fluid. You had maybe 2 + 3. That should be fine. Yeah. And then change the step. Can I give everybody one of these?